Talking about variation today. I don't know why they put this section in the middle of chapter 8. It's totally unrelated, or pretty much unrelated to anything that we've done in this chapter. So it's a good opportunity. There's only 4 sections on this test. So again, this one's totally unrelated. If you've never been in Algebra 2 before today, you could come in and do this section with very little problem, I think. Again, I don't know why they put it in the middle of the chapter, but that's why we're doing it at the end. This will be the last section before you take your test. So there are 3 types of variation. All of these are comparing things, like depth and pressure is one that they use in your homework. The deeper that you go down in the water, what happens to the pressure? It increases. So those are varying together. One changes the same as the other does. So that's what we're talking about with variation. Another one is the speed that you travel and the time that you get somewhere. Those vary. The faster you go, what happens to the time? So as your speed increases, the time decreases. That would be inverse variation. If one goes up, the other one goes down. So we'll get to that. But all of these you do the same way. There's just a little bit different equations that you will use for each one. So we'll go through a few of each, and then you'll have some homework from each one. So the first one is direct variation. And that means that the 2 things you're comparing are changing at the same rate. It doesn't mean that they're both going up or they're both going down. It just means that if one is going up, the other one's going up or down at the exact same rate. And there are 2 ways to solve all of these problems. I'll show you both. That's the formula or equation for direct variation. Y equals kx. K will always be K. It's always the constant of variation. In all the problems today, it is the constant of variation. Y and X can be anything. It can be pressure and depth. But K is always K. K is the constant. It's the slope of this linear equation, if you will. So K doesn't change. K will be in every problem. These letters might, though. Again, D and P would represent depth and pressure, or any other letters that they give you. But K is always going to be that constant. So on your homework, well, actually, if we were to solve this one for K, what would we do to get K by itself? Divide by X. So another way to see a direct variation is that K equals Y over X. So you need to know both of those. You'll need to know this one and the K equals. I'm going to erase the dividing part just so you can see the 2 forms more clearly. So one solve for K, one solve for Y. You'll need to be able to recognize both. So we'll do a direct variation example. If Y varies directly as X, and Y equals 12 when X equals -3. I'm going to stop right there. All of that information right there is given. They're not asking you to find anything. They're not, all that is given information. You have to be able to determine what's given and what you're trying to find on all of these problems today. It says if Y varies directly as X. Okay, so they're telling you Y varies directly as X. And they're also telling you that Y equals 12 when X equals -3. Okay, that's all given. Now, they give you the part that you're looking for. Find Y when X equals 16. So that's what you're looking for. You've got to be able to distinguish between what's the given information and what they're wanting you to find. And sometimes it'll be in different order. I think majority of the time it's listed here where all the given is first, and then it says find. But another way this one could have been written, I think one of the next ones is, if y varies directly as x, find y when x equals 16. I'll just have those two parts flipped around. So remember, the part where it says find, that's what you're looking for. The rest of it is given. So since they told you y varies directly as x, you can use the equation y equals kx. And you can plug in the two things that were given. What was the given y? 12. And what was the given x? What? -3. So k times -3. So how would we solve for k then? Divide by -3. So what is k? K equals -4. And again, that's the constant of variation. That's always going to be -4 for this problem. No matter what numbers you put in for x and y, that's always going to be, k is always going to be -4. So you could write your equation then, y equals -4x, because now we know that that's what k is. So we used the given information to find k. Now we can figure out what y is when x equals 16. So we just plug in the 16 for the x. So what do we get for y? -64. That is your answer. So that's the equation method, if you will, using the equation to solve the problem. That is one choice to solve that. Another way is to write a proportion and solve it. And I guess that's that part, since it's a proportion, I guess that's how they're tying it into chapter 8, was we solve proportions with those equations. If you're going to do that, you set those two proportions equal, so that goes with direct. The y1 and the x1, that first fraction, that's the given again. So these two things are the given ones. The second fraction, the 2's, would represent what you're looking for. So what was the y that they gave to us in the given information? It was 12. What was the x? -3. And what was y2? That's what we're looking for. So you can just put y in there. And what was the second x? 16. So then if you cross multiply and solve that, you will get the same answer. So you would have -3y equals, what's that? What? 192 over -3. Is -64. So again, either one of those methods, you can do the equation method, I guess, or the proportion method, whichever one you prefer. It's kind of important to remember these equations. So if that would be, if you're kind of indifferent on which one to use, I think I'd probably recommend the equation one, just because you'll be more familiar with which equations go with which is important on in some of the other homework problems. So, you know, but again, it doesn't matter which one. If you have the equations written in your notes, that's the important thing. You'll have them there. So the next one, we will talk about joint. Variation. It looks a lot like direct, but with joint, you're comparing more than two. It's more than y and x. You throw in another letter. So you have two things joined together. The equation is y equals kx, and then we throw a z on it. That's what makes it joint. We have more than one thing you're comparing to. So if we solve that one for k, what would it look like? You divide by xz, so k would equal y over xz. So what's the difference there with k between that one and direct? Just got the z down there also. So those are pretty similar. So we'll do a joint problem. Suppose y varies jointly as x, so again, that's given. Y varies jointly as x and z, but now they've got it in reverse order. So when you write the problem down, you can switch that around if you want to. It doesn't matter to me. It says y varies jointly as x and z. It says find y when x equals 8 and z equals 3. And then we're getting the other given part. If, and they gave you all three, y equals 16. What's x equal? 10, 2, and z equals what? Z equals 2. So again, this part here is what you're looking for. So this would be all of the second ones, second fractions or second letters. That will come later. You use the one where it gives you all three to start off with. So the formula or equation, y equals kxz, and we're going to find k using the three they gave us. So in the given information, what was y? 16. K stays K until we figure out what it is. What was X? 5 and Z. So what's K equal? And I would leave it as a fraction. So what's the reduced fraction? 8 over 5 for K. On your homework, when you get to your final answer, I want you to leave it as a fraction or have it written as a fraction and a decimal. For some reason, my grade book goes back and forth. Sometimes it has fractions, sometimes it has decimals. So the best way to make sure you've got it is just to put them both. And it's 2 clicks of the calculator, and you have both anyway. So let's just put them both. So our equation would now be y equals 8/5 x z. We just replace the k, and now we have to find what y. So now we're on the find part. What they want us to put in for x to find 8 and z. So what do you get for y? Decimal or fraction? 38.4, and then what would the fraction be? 192 over what? Now, somebody the other day, their answer ended up being 3, I think, and they wanted to know how. I don't remember if they were trying to write that as a fraction or a decimal. But if your answer is a whole number, an integer, that's it. You know, there is no two things to list. Like our first one, I forgot, negative 64. That's your answer. You don't have to write that as a fraction, or it's actually already is a fraction and a decimal. So those are fine if they come out even. But if they don't, get a fraction or a decimal, make sure you have both. So then, to do the proportion side, you're basically always setting k equal to k. So you'll have y1 over x1 z1 equals y2 over x2 z2. And you have all of that except for one. Just the y2 is the only thing you don't know. You know all the rest. So what's y1? 16. X1 is 5. And z1 is 2. Equals, and again, y is the one you don't know. And the other x and z was 8 and 3. So what's 16 times 24? 3 what? And so we divide by 10. And what do we get? 38.4. There's two different methods you pick. Other questions on those? The last one is inverse. We already had an example of, was the speed that you go and the time that you get there. Those vary inversely. The equation for inverse, y equals k over x this time. Y equals k over x. So what would k equal? How would we solve for k? Take both sides times x. So k equals xy. For that. What do you mean opposite of the other? And this one equals xy. I guess if you want to look at that as opposite, I would just remember that. But so an inverse problem, and I think they use some different letters. I think they use R and T probably for rate and time. If R varies inversely, I always forget that E. Inversely as T, and R equals 18 when T equals -3. So that's all given. Now we're on the find part. Find R when t equals negative 11. One thing you have to be careful with when they don't use x and y is which one comes first. So is this one going to be r equals k over t, or t equals k over r? So whichever one is varying, it says r varies, so that's the one that comes first. In this case, when it's written like that, you can kind of look at varies as the equal sign. So this one would be r equals k over t. And then you plug in the given. What was the given r? 18 equals k over, what was the t? Negative 3. So how do we solve for k there? 18 times negative 3. What? So your k, negative 54. And then you can write your equation again. R equals negative 54 over t. And what t did they want us to plug in? What? Negative 11. So negative 54. Negative 11? Yeah. So what's R equal when t equals negative 11? What? 4.9. And 54 over 11 is the simplified fraction. They're supposed to need to be positive in here. It's a setting on the fixed point. But yeah, no mixed numbers. Her calculator was giving her 4 and something else. Mixed number. We want decimals and improper fractions, always improper fractions. So if your calculator is doing that, I'll have to look at it. But you definitely want improper. There is a section then of homework problems that wants you to just look at an equation and state whether it's direct joint or inverse. So you might have a problem like x over y equals 23. So I would write those equations at the top of your paper, of your homework paper, so that you'll be able to quickly see it. Because now you got to go back through your notes. Which one looks like that? And you're going to be looking at the k equals problems. So here's your k equals xy. That doesn't look like what you have. Somebody already said direct. So k equals y over x. It doesn't matter what these letters are. Remember, x and y could be anything. But your constant k equals x over y or y over x. So when you look at this, you would be able to say that is direct. And what's your constant of variation? What's in the spot of k? 23. So for this problem, you'd write direct. K equals 23. P equals 23 over Q. So again, the number that they give you is always going to be the K. So which one does that look like? Where K is on the top of a fraction. Inverse right there. Y equals K over X. So this one's going to be inverse. And K equals 23 again. Whatever that number is, that's always going to be K. So you figure out which one it matches. We will do 1 through 30. page 468. We skip 14 and 15. But you need to listen up to this next thing I'm going to say, because I'm not going to answer it 73 times when I come around to each one of you. Look at numbers 4, 5, and 6. You can also skip number 7. But numbers 4, 5, and 6 there, it's the same type of problem. They're giving you pressure and depth. You have to look at the picture next to those numbers to get the pressure and depth that's given. So from the picture, what is the given pressure? 4.3, what's the given depth? 10. And looking at the given information in the problem, how are they varying? So you got to read the first. They're varying directly. So you should be able to write your equation since you know what's varying and how they're varying. It's the same as me telling you y varies directly as x. You can write that equation. So do the same thing with those three problems.